And now I would like to introduce our guest speaker, Damon Tighe. Damon, it is such a pleasure to have you here. I know you've been working so hard. You're so well known in the community. I've known Damon for decades, really, as a teacher at Oakland High School. He was just amazing in providing curriculum and encouragement to me as a teacher and to other teachers there. He works now for Biorad as a curriculum developer. He's also a co-founder of the California Center for Natural History.
It's a mouthful.
It is, and you changed your website.
Well, yeah, that's a whole other thing. Our URL got pulled. Yeah.
Yeah, but I found we will have it in. You can go there now. We will have it in the chat so people can go there and see the wonderful things that you do. So I think I will include a bio in the post letter. And is that okay?
Yep.
And we'll let you get on with the show. And I really appreciate your coming on. I know you've been working all day on this problem. And
I appreciate you having a longer intro because it allowed me to add 2 more slides to this deck. It's been one of those weeks, but I mean, I think everyone around the lake is feeling that right now, and the San Francisco Bay. So with that, good evening, everybody. My name's Damon Tighe. Thank you, Katie, for the introduction. And also thank you for years of mentorship around Lake Merritt. Over the years, I've learned so much from watching Katie bring students to the lake, what she shows them, what she does as far as long-term monitoring. And these are the type of things that we need in more waterways in Lake Merritt, in the San Francisco Bay, and around the world as kind of eutrophication takes place and we see algal blooms. So with that, I'm going to start sharing my screen and we will jump into the presentation for tonight. Let me just make sure that that screen share goes smoothly. Of course, it's going to share how a presenter shows it first. And there we go. I think hopefully now you're seeing just the slide deck and none of my scrappy notes. So Katie had originally invited me over to do this talk months ago on a great note, which is the bioluminescence in Lake Merritt, which is super exciting. And this would be the time of year that it would just be beginning. And to some degree, it does relate to what's going to happen tonight because bioluminescence in Lake Merritt takes place due to algal blooms and the subsequent organisms that are on the tail end of those blooms. Some of those do cause bioluminescence. And then, as Katie brought up, August 28th hit and everything kind of changed. And so we were quickly talking about just doing a talk on the fish die-off in Lake Merritt. And then as things started to unravel further, the talk's going to be about the San Francisco harmful algal bloom, or a HAB, that has been going on since, it's really been going on for about a month and a half, 2 months at this point, if you really trace it back. I struggled with putting this together because a lot of the talks I do are more of like, how do you put this, old science lecture, kind of drill and kill. Here's the points, let's walk through them. But with this one, there's no way to do that. So you're unfortunately going to have to deal with storytelling from me about what I was seeing on the ground, what I was putting together, and then we'll dip out to look at data that a bunch of these agencies are putting together in order to understand what's going on, and then what steps we can take as a community to kind of build resilience against these events being more frequent in our future. Because it's going to be very hard, I think, for us to avoid these in the next coming years. But over the long term, I think there are some ways that we may be able to avoid them for decades to come, but it's going to take a community. So I didn't want to drop the bioluminescence all the way because, damn, that's fun. So we're at least going to spend 2 slides there. So for those of you that don't know, bioluminescence, especially in marine estuaries, is a relatively common phenomenon. You see it all across the world. And I'd always been getting basically little tidbits of it from rowers and stuff in Lake Merritt for years. And I was basically just telling them, hey, when you see it, you just got to let me know because I've got to go out and document it. I at least want to see it glow, and I'd love to be able to identify the organism. So in 2018, thanks to Mandy Bliss, Phil Clark, and Trang, I got a tip off that, hey, we were out rowing yesterday and we saw bioluminescence. So I grabbed Joey Santori, who used to be a botanist living in West Oakland, and said, hey, man, you got a kayak? And he's like, yep. I'm like, all right, you're coming over tonight. We're popping ourselves in Lake Merritt and trying to find this glow. And so this is what we saw. So when you would hit the top of the water, you had just these huge blue currents of light. Very amazing that you could see it with all the bright lights of Oakland around. After much digging, All I could do was get it down to a genera that was probably causing the bioluminescence. Going into this, I thought, you know what, it's probably like a handful of species in the world that do this. Just the opposite. Like it just became a black hole of like, oh my God, there's so much in here. Hundreds of species. I tried talking to folks at UC Santa Cruz, UC Santa Barbara, and they helped me narrow it down based upon microscopy I'd done. And to be aware, Lake Merritt and the San Francisco Bay goes through algal blooms every time we get towards the end of summer because things are warm, there are nutrients around, especially in stuff close to the water. And so this wasn't the only organism. There was a whole bunch to choose from. Here's a couple of photographs of them. It is like a giant, amazing safari this time of year in the water under a microscope. So some folks in the audience, potentially like Janai and folks like that, do this really well. I'm just here playing around. And that actually brings up a really important point, which I want to kind of put out there is your presenter's biases. This is always good for any presenter to do at the beginning of a talk. I am not a marine biologist. I'm not a hydrologist. I'm not even an estuary ecologist by training. I'm a molecular biologist. And so I'm coming at this from very much the amateur, the one that loves the thing, but maybe isn't necessarily a career person in these fields. So that's just important for you to realize during this talk. But I've spent about 20 years poking around Lake Merritt, trying to understand who's there, what they do, how they interact. And a lot of my knowledge is piggybacked off of the decades of work, Katie, Doc Bailey, all these other folks. So my story around the Lake Merritt die-off actually starts on August 2nd. I was flying out of Oakland to go work up in Corvallis, Oregon. And I happened to just be sitting on the right side of the plane to see this. I'm looking out the window and I see this dark channel in front of Alameda. And it kind of stretches up, goes, and it hits basically Treasure Island, Yerba Buena, and then kind of breaks apart. And I was looking at this and you can see actually streaks where boats are going through it. And I'm like, is this an oil spill? And so when I land up in Oregon, that's the first thing I'm doing. I'm checking to see, is there an oil spill in the Bay Area? I'm seeing no reports, no anything. And so I'm like, I mean, it's got to be, is this an algal bloom? And my first thought is, oh no, was there an accidental release of additional nutrients into the bay? Because you have to remember, all of the bay communities, for the most part, our treated wastewater goes into the bay. And so the candidates here were going to be East Bay mud, which is predominantly Oakland's stuff, and then EBDA, which is predominantly San Leandro, Livermore, Hayward, Castro Valley. And they're kind of at opposite sides of where I saw this channel. And so those were my kind of first like, uh-oh, is something going on? And here's maps of where those two are at. The stars on the previous map gave you that. EBDA is kind of directly west of Alameda, or sorry, directly southwest of Alameda, where East Bay mud is kind of underneath the Bay Bridge before you get to Treasure Island. And just to put it in context, not to point them out, because there are 37 agencies or more that treat wastewater and they end up within our San Francisco Bay system. And this is something we're going to circle back to at the end when it comes to this algal bloom. So I got back home and I no longer reside right up against Lake Merritt at 1502 Alice Street. So it takes me a little more time to kind of filter my way over to the lake sometimes. So my closest body of water when I got home is the San Leandro Marina. And so I figured, because I saw that and I had the impression that might be an algal bloom, I just wanted to go check there. And sure enough, when I get to the San Leandro Marina, it is this just ridiculous golden color. Photographs do this no justice. Anybody that saw this in person realizes that all your photographs just don't capture the color of this. I took it home, did microscopy on it, and it matched what a handful of people had already identified going on in front of Alameda. I believe Waterboard is involved in this. I think Janai was probably also involved in this. And this was an organism known as Heterosigma akishuo. Seen it in San Leandro, I thought then in the back of my head, uh-oh, is this going on in my beloved Lake Merritt, where I've spent lots of time looking at organisms? And so on August 10th, I planned on going up there. In the course of meeting people during this event, I bumped into a fellow, Harvey Castro, who lives around the lake, who's a photographer. And he, bless his heart, was out at Lake Merritt early in the morning and captured it when it was first coming into Lake Merritt. So what you see here is that golden mix, kind of the cream versus coffee look. This is that algal bloom entering Lake Merritt at 6:43 in the morning. I'm a late sleeper, I guess, compared to Harvey, so I did not get to the lake until about 8:30 a.m. So remember, not too much long after, and it's completely well mixed, at least by the Green Bridge, which is my usual jump off point for Lake Merritt. I take a dip there of water into a sample, not myself going into the water, take it back, also do my microscopy, confirm, yep, this is also heterosigma again. And then that starts me thinking, uh-oh, what do we know about this organism? Actually, before I even get there, I first shoot an email out to EBDA because East Bay Mud had already contacted me based upon those photos. And I basically asked them, hey, are any of you guys having a spill? And everybody was like, nope, there's no accidental releases we're aware of. All of our monitoring is not showing anything aberrant going on. And so that gets me thinking, well, what do we know about this organism? And when you dig into the literature with this, it takes you all kinds of places. And everything from, this has a potential neurotoxin similar to TTX. So if you guys are familiar with TTX, the toxin, that is what our Tarica turosa, our rough-skinned newts have in California. So if it has a toxin, it's operating in a similar pathway to this. This is an organism that is seen all around the world in large algal blooms. So the map there on the bottom are documented cases of large algal blooms of Heterosigma akishiwo. And so it's basically both hemispheres in large metropolitan areas where you've got waterways with additional nutrients. Closer to home, though, there were some really great papers from the Puget Sound that really kind of dig into what do these effects look like from this organism. And the thing that really kind of distills out of me that afternoon is that we should be expecting the fish die off with this. And so this is August 10th. But the caveat there, and this is something that actually Katie brings to my attention through a conversation with Jim Carlton, is that what we call Heterosigma akishiwo might actually be a cryptic species, i.e. we've been using the same name to describe a number of different organisms. And some of these papers dig into that a bit, calling them strains. And this kind of complicates using literature research to understand what's going to go on, because we might not be talking about the exact same organism. And so for our bloom, I really hope that somebody is doing molecular work to help further characterize who this is and not just taking the microscopy and saying, oh, we're working with Heterosigma akishiwo. This is something that needs molecular work to make sure that we know who this organism is. So that same day after doing the reading and then kind of getting that feel in my gut, I just kind of put out a small notification through some of the Facebook sites around the lake, just saying, hey, this is going on. I know a lot of folks are seeing this. If you could just keep your eye out for dead fish, because these are associated with fish kills. And to my surprise, nothing happened, which was great. So it actually fell out of my mind. I didn't think about it for weeks. In fact, kind of 2 weeks go by and I started thinking about other things at Lake Merritt, my other passions at Lake Merritt, which is looking at the fungal diversity. And I saw through a Facebook group that somebody had seen a mushroom at Lake Merritt that is unusual for our lake. And so knowing Katie's program was going to happen on the 28th, and I needed to see this mushroom to get a DNA sample, I went, I'm going to be at Lake Merritt bright and early on the 28th to go pick up this giant sawtooth mushroom, so a mushroom we usually only see in the Sierra Nevadas and rarely see in the San Francisco Bay. And bless Oakland's heart at leaving a dead tree there for years so that these things could occur on it. Decay is a great thing. Some city parks manage this very well. Seattle does a fantastic job of decay as life as part of their parks. Oakland, I don't know if this is conscious, but they accidentally do it occasionally. So we're benefiting from this. On my drive in, I got an email from Timothy below to the CLFM group saying, hey, there's something weird going on at the lake with dead fish. And I kind of got this feeling in my stomach about that original August 10th literature dive. And so when I got to Lake Merritt, I grabbed this mushroom where Brooklyn hits the east shore and then walked over to the shore right there. And that's when I first kind of realized what was going on. That shoreline was already kind of littered in our yellow gobies, a dominant fish in Lake Merritt, originally from Australia. And then I went, how widespread is this? So I go down to my favorite spot, the Green Bridge, and this is what I see. I mean, we're getting to the point where in places there feels like there's more fish than grains of sand. It's mainly yellowfin goby on the morning of the 28th, but there's other big critters there too. Striped bass are already starting to die. Green crabs are dead. There's anchovy there, the one with like kind of the lock open jaw. There's the first flatfish I've ever seen up close in Lake Merritt. I know Adrian has seen one before with his open ROV device, but this was my first chance getting to see one. In fact, the really sad thing is I'm somebody that spends a lot of time at Lake Merritt poking around. I saw a handful of species that day that I'd never seen at Lake Merritt. And this is something that kind of plays out through the course of the day as I'm walking around the lake, is all of these people are just stopped in their shoes, looking at the lake, going, first of all, oh my God, a bat ray. Oh my God, fish. And then it kind of hits them what's going on, that they're dying. And so it's just this kind of like mass tragedy as it kind of ripples through the community. So after the Green Bridge, I decide I need to figure out how widespread is this. So I start my walk around the lake and just kind of taking iNaturalist observations along the way. Basically taking my cell phone, taking a picture of dead fish when I see them, and not every dead fish, because I wouldn't have got out of there for weeks because there were so many. Easily 10,000 dead yellowfin goby that morning. But what occurs is it's the entire lake. It's entirely ringed with dead fish. And so I think it's really important that you see how they are dying, because this is what's playing out also in the San Francisco Bay. So what we're seeing here are these are yellowfin goby that are trying to get air. So they're up at the surface trying to pull oxygen down. And as you pull back, you find all the ones that haven't made it. So these are all the ones that have already suffocated. And there's another group of them trying to breathe over there. Also in the Glen Echo Channel, we're seeing all of the large organisms back in there, because my assumption is that dissolved oxygen back in that corner must have been better that day than in other places. And that's partly, I think, due to the way the algae flowed in. I think it flowed into the kind of the Embarcadero arm out to the boathouse first, and then came into Glen Echo second, based upon talking with Harvey and Katie. I think some of your folks may have also mentioned that too. So here's one of the bat rays in Glen Echo. Bat rays don't do this. They don't hang out at the surface. This one's trying to get air. It is suffocating. This is one of the hardest days I think I've ever had in Oakland, seeing all this death in Lake Merritt. Around noontime, I really wanted to go spend the rest of the day with Katie's event, because she brought in so many cool presentations and groups to talk about the dynamics of our waterway and of Lake Merritt specifically. But then I just couldn't, because I needed to kind of see what was going on. And the one piece of data I really wanted was this, which Katie sent out to me, I think at noon. And this was a dissolved oxygen reading that she or the students did. And what we see is our dissolved oxygen is practically zero at this point. It's way beneath 1, at least in this reading that was sent out to me. And you got to remember, like, under 5 ppm is stress for most aquatic life forms. Below 2 ppm from a USGS point of view, this is officially now a dead zone. And so on this day, Lake Merritt, as far as we can tell, a good portion of it was dead zone. And that's why we're seeing all these fish dead out there. People use different metrics on the backside of this, or descriptors. So one, just so that you know, this 1 milligram per liter is effective to 1 ppm dissolved oxygen, because USGS will use 1 milligram per liter in most of their readings that we'll come up to later. So August 29th, well, actually, I didn't put this in there because I didn't have time. After I saw Lake Merritt, my first impression was, crap, how widespread is this? So I went out to where the channel meets the estuary between Oakland and Alameda. Yellowfin goby also out there gasping, a few of them dead. I go out to where Bay Farm and Alameda connect, and I find dead marine worms there, dead polychaetes. I don't find any dead fish right away, but talking to fishermen, a couple of them point out some dead stripers that were already showing up there. So this is my first indication that maybe this just isn't Lake Merritt and something else bigger is going on. But at that point, I've run out of time for the day. August 29th, I roll back. And now that entire Glen Echo section where all of the big boys went, all the stripers, all the bat rays, they suffocated that night. So you got to remember, algal blooms, at least when they're first getting going, anoxia is worse at night, because all of these organisms that are photosynthetic during the day, they're doing cellular respiration during the day, but at night, they're no longer doing the photosynthesis. So they're not pumping out O2 into the water, but they are gobbling it all up. And so you have a full drop back down to very low oxygen levels. In a very small walk between the cathedral and Lake Chalet, I counted 522 dead stripers. 522. This is a small portion of Lake Merritt. I didn't have time that day to walk the rest. I had like work commitments. 39 bat rays. I think the most bat rays I've ever counted in a single day at Lake Merritt has probably been, under like around 5 at best. This was huge. And then small fish still in the tens of thousands. And what we're seeing now is, instead of just yellowfin goby, we're seeing some of our other small fish get caught up in this die-off, things like anchovies, things like smelt. I come back on August 30th, and now is the large die-off of the anchovies. So on the 29th, there were still anchovies kind of swirling around places and smelt, and they were mainly going to where water was still coming in through some of the drainages by Glen Echo and even just through some of the surface street runoff. That's because that water was still oxygenated when it was showing up, and they were able to use that. By August 30th, all of them are dead. I no longer really see schooling fish over in Glen Echo, but I do find just thousands of smelt and anchovy dead. And now another disturbing thing to me is I'm starting to see the shellfish open up. So our Japanese littleneck clams are open, our mussels are open. The bottom of the food web is basically unwinding in front of our eyes because we've been anoxic for so long at Lake Merritt. So that night I go home, I start an iNaturals project, but in my brain, I'm still just thinking about Lake Merritt because I haven't gone out to the rest of the bay yet. In fact, I don't even have a good pulse that this is going on big time in the rest of the bay. So I start this project thinking that people just kind of will start participating around the bay. Maybe we'll see some other stuff going on, but I never thought it would be the impact that it would as far as the die-offs around the bay. So I think I get that project built at like 2 a.m. in the morning because it's just one of those nights. And by 8 a.m. I wake up and there's already 100 observations coming in from all over the bay. And I go, oh, this is really big. And by today, we're well over 1,000 observations. 440 of those are sturgeon. And we'll dig into that a little bit later. And this is not just Oakland anymore. This runs from Napa County all the way down to Santa Clara. There's no part of the bay that is not touched by this, i.e. dead fish rolling up on shorelines. This is huge. But what really happens, I think the heroic thing here is the number of people that kind of pick up the torch and say, I want to go out there and make sure that we don't miss something. I want to go out and observe. And so many people jumped in and got out there with their cell phones, the iNaturals app, and started recording what was going on. And the beauty about iNaturals was that people could see where other people have been because there was data points there. And so I had people constantly texting me saying, hey, where can I go? Through Instagram, through text, through Facebook, all these social media things. And I could go on there really quickly and say, hey, it doesn't look like anybody's looked here. Could you go there? And this is what allowed us to get this really quick coverage. I mean, I would say by day 2 or day 3, we've basically pulled in most of the San Francisco Bay counties as having dead fish at this point. Just to give a feel of what we're seeing right now in the data, at least 73 species of dead things involved all across the bay, over 1,000 observations, over 130 people involved. And literally, when I get done with this, if I go back in that project, there'll be more observations and more things still rolling in. Luckily, though, we're seeing the ebb of all the dead stuff kind of slowing down as the oxygen levels around the bay, around Lake Merritt kind of get better. But the reason I kind of highlight some of these organisms is to show you it's not just fish. The focus for many people is fish because they've got strong personal connections with them. They can relate to them more, right? A lot of people don't relate to like those beautiful polychaete worms down the bottom corner, but all of this entire food chain is getting hit by this low oxygen event caused by this algal bloom and potentially by a neurotoxin with this algal bloom. But that is still being figured out. Waterboard and some other agencies are doing testing to figure out, is there a toxin involved with this specific bloom? So they've taken fish samples, they're looking in their tissue, and they're looking in water samples. Let's talk about the sturgeon die-off, because this then is why this becomes not just, some invasive species are dying off in Lake Merritt, we'll forget about this. This is what brings in agencies, is when threatened or endangered fish start dying off, and ones that are really big from a recreational point of view as well. So redwood or sturgeon, if you're not familiar, are these really large, decades-old fish, and a lot of the ones that rolled up during this event are big ones, 4 to 7 feet. This is not a small fish. So the photographs there at the right, these are, I think this was the 29th or the 30th, or probably the 30th when I went up to work. And so these are just like out in front of my work in Hercules, California. They don't hit breeding age until they're like somewhere in their mid-teens, which means recovery time for a massive population die-off, like what we just went through, is something I can't even imagine. But I hope CDFW is able to put numbers to that, because this is a fishery we've now got to really watch, especially if we anticipate having more of these HABs, harmful algal bloom events, in the future. These organisms are also just historically very old. So you can find fossil record of them in the Cretaceous period, right? Cretaceous period. Let that sink in, right? way, way back. These are ancient organisms, at least from a body plan. I'm sure evolution was still having effects. We just can't see some of that evolution because it's too small. This map on the left here, this is where all of the dead sturgeon were found. So as you can see, it's all across the San Francisco Bay, and even a couple stretching out a little bit into the Delta, but the Delta seemed protected. The bloom didn't seem to come out there and kill sturgeon, which is good. Let's dig into the two species we have locally. We've got the white sturgeon, which is probably the best known one because it's the one fishermen can go after in the bay. It's also North America's largest freshwater fish. So these can get up to be 14 feet in length and up to 1,500 pounds. The oldest known one is 103 years old. They predominantly stretch from kind of San Francisco Bay up into the Pacific Northwest. And what you see here on the right is actually on the Columbia River at the Bonneville Dam outside of Portland. There's a great white sturgeon display where they've got this just beautiful, massive Hermann sturgeon that you can go visit if you ever come through the Columbia Gorge. But they're just amazing, magnificent fish. I mean, they're really kind of like the redwoods of our waterway. They're these old things that when you see them, it just changes your relationship to that space because you're like, I can't believe this thing lives here. It just is. It's almost hard for my mind to be wrapped around how big, how ancient these critters are. And then the one that really gets the Fed's attention is the green sturgeon. And that's because it's on the federal protected species list. These get up to about 7 feet in length, about 350 pounds. Their geographic range is about the same as the white sturgeon. So from kind of the San Francisco Bay up into the Pacific Northwest. They're differentiated due to their smaller size, and the fact that their coloration is green. They have scutes, the kind of bony things on the exterior that you can easily see in different locations than the white sturgeon. And then also their fin ray count is a little bit different. But we had at least 14 of these come up during this event dead. This is a big deal because there's already not many of them. If these events continue to take place, I don't know if the potential for localized extinction might happen, but it was something that I would at least be worried about. And I know CDF is worried about. So like I said, a lot of people, sturgeon are the things that kind of pull them in because some of us have some very long personal relationships with them. And I'm one of those people. I didn't grow up in the San Francisco Bay. I grew up in Calaveras County. Probably none of you know where that is at unless you read Mark Twain a lot and you remember the jumping frogs of Calaveras County, basically two guys getting drunk in a bar and betting whose frog could jump fastest, which was a big portion of my county's income for years going forward. But I would come down and I'd visit my grandpa Jim in Stockton, California, which is of course ultimately connected to the bay through the estuary system and through the Delta. Grandpa Jim was OBGYN, but in his spare time, what he loved to do was go fishing for stripers. In the process of catching stripers, he would occasionally fish for sturgeon. Not to bring them home, necessarily put them on the table, but to kind of just get to see them. And so I think this was the first sturgeon I ever caught. And I think that same day, I think we ended up pulling up one of those just mammoth ones. And it completely changed my view of what was in that water. And this is one of those things that I think is in danger of future generations not being able to see. And this is why we need to really rally behind what caused this event. How do we prevent eutrophication taking place throughout our Delta system? Because there are algal blooms right now going on in Stockton, and we've got this big one going on in the San Francisco Bay. So this almost wraps up my story time about my experience with it. On September 3rd, throughout this week now, I'm continuing to try and get out and just survey as much shoreline as I can. But by September 3rd, remember, this isn't many days out from when the initial die-offs start. Fish are decaying so fast that it's really hard to see them. Remember, like mini foot-sized fish, and it's getting hard to see them. The only thing I'm able to find a lot of times now are these massive skulls from sturgeon. So these are ones that were found out in front of San Leandro on the 3rd. State Water Board puts out I don't want to say late, because they put out some notifications earlier too about the algal bloom going on, but then that they were worried that there might be an additional fish die-off that would start taking place this week due to these warm water events that we're getting from the hot period that we've all just kind of passed through. So one kind of factual piece I want to hit again before we jump into some of the agency data and who's involved in kind of figuring out what's going on, what the effects are, how we can maybe strengthen ourselves against these in the future is, how do algal blooms lead to O2 depletion that cause death? And there's kind of two main ways that it takes place. So during the original algal bloom, when you got the organism is, rapidly dividing, you're getting this giant biomass of that specific organism. Remember, all of a sudden, you've got a lot more organisms in the water. During the day, that's kind of, not the worst thing because they're harvesting light, they're harvesting carbon, and they're basically letting go of oxygen through the process of photosynthesis. But then when nighttime hits, you now have all of these new community members that are also gobbling up the oxygen. And so you see these dips in oxygen at night due to that portion of the bloom. And then where it gets really bad is when that bloom starts to die and those organisms start falling down the water column. They're basically food for other organisms. Other organisms, as they're eating them, are metabolizing them. That uses oxygen, and that just causes that O2 just to kind of keep dropping. So those are kind of the two ways that these large algal blooms can lead to O2 depletions that lead to die-offs. And this is what I'm focusing on because like this, we've got really good data for at this point. Remember, there's still the big asterisks of, is there a toxin involved in this bloom as well? So take home points from my observations throughout kind of the last week and a half. The major hit was Lake Merritt. Lake Merritt is kind of a canary in the coal mine for the rest of the San Francisco Bay system for a number of reasons. A, it's a smaller body of water. We already know it has O2 problems occasionally, and there's a lot of eyes on it, like that canary in the coal mine. And so we're able to see an event happen there much faster than any place else in the bay. And just due to the flow dynamics, a lot of the dead fish don't just disappear from sight really quickly. So you got to remember in the bay, we're only seeing the stuff that dies, floats, and then bobs its way to shore. At Lake Merritt, we're lucky that when the tide goes out there, those dead fish, we can get out on the shore and kind of see them really quickly before they vanish. And a lot of those gobies, when I came back the second day, were gone because a little bit of tide came up, picked them up. Now they're at the bottom. I can't see them anymore. So Lake Merritt, I feel like, gives us a really good window onto potentially what's happening in the rest of the bay, which is, a complete disruption of the entire food chain. And it really gives us an idea of how those O2 effects maybe sequentially also affect the food chain. And you got to remember, this ultimately is going to affect our charismatic fauna. So a lot of people come to Lake Merritt to see the birds, right? Anybody that's been out there this week to see birds knows that this is a totally different place. Our fishing birds are not really there. The only folks that are there in good numbers have been seagulls. Everybody else is kind of left because there's nothing to eat. And this is going to be a big ripple effect going forward. Talking to people in Alameda when me and Janai and Mary Spice were out there trying to do dissolved oxygen a few days ago, people were saying the same thing out there. Hey, this is usually full of pelicans diving, and there's no pelicans here. Where are they? And so my fear is that we still haven't seen all the effects from this yet. We're going to have a ripple effect as that food chain disruption goes up in levels. So that's birds, that's pinnipeds, or seals, or sea lions, things like that. So I really encourage everyone that's listening to have that in the back of your mind when you're going out and hanging out in the bay. See if you see unusual behavior, write it down, document it. We really want to know what this event caused because it'll help us understand it more, and it'll help us understand when this happens again. And I hate to say this is going to happen again. We want to understand what that might look like, and are there things we can do to help mediate the problems as they unfold. And I think the big thing to think about here too, and this is really hard for a lot of people, even me, is that to conserve those most charismatic organisms, we really have to protect the most uncharismatic ones. And I think that's a really hard thing for people because a lot of us don't really relate to marine worms. We don't really relate to mollusks, but watching them relating to what they do for those other things we really like is really important. So just to kind of highlight that, because that's what brought me into Lake Merritt, was actually looking at those weirdos, because I must be a weirdo. Here are some of those wonderful, uncharismatic organisms from Lake Merritt that we lost in huge numbers the last week and a half. And these are some of the things we want to start caring about. Extend our love out beyond the birds, out beyond the seals, extend it to everything that's in our waterways. So now let me dig into some of the agencies at play, the data that they've started to share, and kind of like what this means at a big picture point of view. And remember, once again, not a marine biologist, not an estuary ecologist, molecular biologist training here talking. So if I misspeak, please somebody feel free to say, hey, Damon, I think you're wrong about that, because you know what? Having humility and being able to say, hey, I don't know, is the biggest thing in solving most problems that we face. So involved in this has been a handful of agencies and players. I just want to shout out to a couple of them that have been very out there in the public about what they're doing and their data. So Baykeeper, San Francisco Estuary Institute, California Water Board, CDFW, the California Department of Fish and Wildlife, USGS, Berkeley's Department of Environment, Science and Policy, Lake Merritt Institute, UCSC has been involved in this with some of their satellite data, San Francisco Estuary Partnership. We've got groups from Davis involved, and I apologize, Cal Academy and iNaturalist. I dragged you into the mix by using iNaturalist to document this stuff, but it's really a great tool to bring in the public and allow us to help these agencies see what's going on with one of these events. So one of the big players, and God, this brought me back on Twitter. I haven't been there in like 4 or 5 years. I tried to stay away from that dumpster fire, but it is really the place that a lot of this data gets shared really quickly. So I went back on there, and these are some of the folks that were really helping out. So dissolved oxygen, Keith with USGS got some probes out to the San Mateo Bridge and the Dumbarton Bridge relatively fast, considering what was going on. And this is some of the data, and I just pulled these literally while Katie was giving you guys the intro, so that you've got the latest updated information. So you can see there that as we're coming out of when we saw the kind of fish die off at Lake Merritt, that we see the San Mateo data drop down into the dead zone. Same thing with Dumbarton. But as we progress towards today's date, we're slowly rebounding, which is great, right? We're not staying in that dead zone for an extended period of time, but we were still in that dead zone for a really long time for organisms down there, right? A lot of them are dead, and we just can't see them unless somebody wants to get open an ROV down there and poke around. But the shining light is that we are coming back up. Those O2 levels are getting back up. I would say just within the past 1 or 2 days, we're kind of getting out of that stress zone. So above 5, parts per million. This data is all publicly available, so you can go there and watch it on your own. You can just go pull it from Keith's Twitter feed. The other one that Keith shared, and I think this is coming partly out of some of that UCSC data mining, was this visual of basically chlorophyll from satellite images from the start of August through the end of August. And I think this actually really helps paint a really good picture of how the algal bloom progressed. And remember, with this type of data, we can't say, hey, that's heterosigma down there, because you got to use a very different lens. It's much closer to see that. But it can let us know, hey, there was a massive growth in organisms that were absorbing where chlorophyll, where kind of phytoplankton absorb at. And what we see is 8.3, right? This is pretty dang close to when I was taking that flight. And right there in front of Alameda, I see that bright red line. That's what I saw in the water. This is always nice when you have data that reconfirms what the other one saw. And then as we progress forward, and actually let's do this first. We see that line in front of Alameda. Also, let's look down the South Bay. The South Bay is really known for having blooms kind of yearly anyway. And so we definitely see that going on down there. And we see a little bit around the edge of the North Bay. And then we see this kind of accelerate over the course of the month, where it gets stronger and stronger and stronger. Remember, fish die off at Lake Merritt is the 28th. I would say somewhere between 822 and probably 829 is kind of the peak of the bloom experience. And this is probably where we're getting those major kind of anoxic cyclings at night. And as we kind of move probably from the 26th out towards the 30th is where we're getting the oxygen drops from these organisms now falling down the water column, other things gobbling them up. But we can really have now a strong idea of how this plays out in the San Francisco Bay system due to this visualization. But now the big question becomes, well, what the heck caused all this? Because man, none of us want this to happen again, right? So what caused this? San Francisco Bay Estuary, it's not like a simple billboard, billiards board, Newton sort of physics question of what are my handful of variables and how do they interact? The number of variables is staggering when it comes to biological activity in the San Francisco Bay. So there's all these things to try and manage, right? And so what a lot of folks have done during this, including myself, is just trying to be like, well, what are the biggest ones? What are maybe the biggest drivers that we think are involved here? Let's focus on those, do some deep data dives, and figure out what's going on. Because remember, we're in climate change. We've seen temperatures go up, right? We've all talked about sea surface temperatures in the bay and things like that that are abnormal. We know we've been in droughts. We've got less fresh water coming down through the delta system, which also means we have less particulate matter coming down through the delta system. The decrease in particulates in the delta can increase algal activity because all of a sudden there's not particulates blocking out light getting further down into the water column. But the big one for I think everybody is probably nutrients. And that's because we all know that we've been playing on a fulcrum for a really long time in the San Francisco Bay. In fact, I would say that's really important in this because we know, talking with all the different agencies, there are no obvious signs of an anomalous release. Remember, these agencies are really good about reporting this because there's big fines associated with them, and they are very good at controlling what goes on, or doing their best to control what goes on out of their pipes. This paper here on the right, which was published in, I think it was submitted in 2019, but it actually gets published in 2020. This paper more or less predicts this event. So I'm just going to dig into a few pieces of this. Graphics on the right. Let's talk about the data, how they get this data. So it's a long multi-year study of multiple data points across basically the delta, coming all the way out through the San Pablo Bay, going all the way down to the South Bay, and basically looking at all of these factors that we know are involved in potential algal bloom behaviors. And a lot of this is the nutrients. So nitrogen and phosphorus are the big players usually when you talk about nutrients, just like the plants in your garden, right? If you're trying to get good plants, what are you usually trying to make sure your soil has? Lots of additional nitrogen, phosphorus. It's the same thing in the bay system for algae. What they want, nitrogen and phosphorus readily available. So if we look at the graphs on the right, the top one there is nitrogen levels in many different water systems across the world. And a lot of these, if you look at them, these are ones that you've probably read about having algal bloom events, right? Tampa Bay, Chesapeake Bay, look at how low they are to San Francisco Bay. And then let's go down to phosphorus. We see the same thing there. And so the thing that you can quickly glean without going into all the details of this paper, because there's a lot of gems in this paper, is that we have been playing up at an upper limit with nutrients for quite some time, and it's surprised that we have not been burned yet. And so I think this is why when you kind of listen to a lot of the agencies right now, a lot of the focus is on the nutrients as being the big highlight. In conversations with folks, just kind of put some numbers of where these nutrients are coming from. 60% is through wastewater treatment. 15% appears to be coming down through the delta system through agricultural runoff, and another, somewhere around 15% is coming out of, all of our yards, urban runoff, things coming off the streets and ending up in the bay. And so if we're going to tackle this, you always go for the biggest chunk of the pie first, right? Which is that giant 60%. And this paper actually kind of I think things were already moving that direction. Agencies were already moving that direction. There were already big studies going on, even ones estimating how much is it going to cost to get us back down below a bunch of these other values. And so right now, I would say we just went past that tipping point for the San Francisco Bay. And we think that it's the nutrients that are having this effect. So how do we get these under control? Well, what can we do for Lake Merritt first, right? That's what brought me into this. It's not because I'm out at the San Francisco Bay. It's because I show up at a place I love and everything's dying. Well, one of the things we can really do for Lake Merritt, I think, is reinvesting in understanding the dynamics of Lake Merritt. Just like the San Francisco Bay, the number of variables that go into dissolved oxygen, nutrients, all these other things that are going on at Lake Merritt are really complex. And we've got okay data sets on them. LMI, Katie, Merritt College, a bunch of people have been kind of pulling what they can in order to do stuff, but it's all out of amateur love. And when I say amateur, I mean this in the best way. I'm an amateur at Lake Merritt. I'm one that loves this place and wants to see things happen. We don't have a lot of funding around this. And so there really needs to be some more funding that comes in to really study what's going on at Lake Merritt, because this is what's going to allow us to make educated decisions about how do we modify this waterway, or what do we do with this waterway in order to avoid these events in the future. One of the short-term things we can do is invest in the current oxygenation of the lake.